setting up and solving simple non-linear equations. So the first thing that we've got over here is f to the power of 3 minus 2 divided by 2 equals 31. So this is exactly the same as what we'll be doing with a linear equation and solving. But instead we've just got a bigger power. So the first thing we need to be thinking about is the same thing. Is that when we've got something on top, it's like we've got them in brackets. So we need to treat it as such, which means the first thing that we need to be doing is multiplying both sides by 2. And that is so we are able to cancel out our divided by 2. So I'm going to times this side by 2, and I will times my other side by 2. So that's going to leave me with having f to the power of 3 minus 2 is equal to 31 times 2 is 62. The next thing I can see here is that we've got a constant on both sides. So like always, we need to get rid of our constants. So the first thing I think about with that plus is that negative 2 is to get rid of it to 0, we plus 2. But that also means we plus 2 to the other side. So that leaves us with the following equation. F to the power of 3 is equal to 62 plus 2 is 64. Now, next thing that we need to be thinking about is thinking that we want to get rid of the power of 3. So we need to do a cube root. I'm going to cube root both sides. That leaves me with just f. Now the cube root of 64 is that you need to be thinking about 3 numbers that times together to equal 64 is 4. Because 4 times 4 times 4 equals 64. Okay, I'll clear this off and we'll look at the second question now. Okay, so our second question is slightly a bit more challenging, but it's the same thing. We are just needing to look at this question in terms of the equation. So we've got the volume V of a cone is given by V equals 1/3 pi r squared times h, where r is the radius and h is the height of the cone. Find to the nearest centimeter the radius if the height of the cone is 15 centimeters and the volume is 392.7 centimeters cubed. So, the first thing I'm going to do is put that information into my equation. So straight away it says my volume is 392.7. So 392.7. Then it says it's equal to 1/3 times pi. Pi, if you don't have a calculator, we'll just round it today, is 3.14 times radius squared. Now, the radius, if the height of the cone is 15 centimeters, so we don't have the radius. So we've got radius squared times the height, which is 15. Now, we can simplify this just to make it easier for ourselves. So we are going to go 1/3 times 3.14 times 15. So that is equal to 15.7. So that leaves us on our right hand side with 15.7 r squared. And we've got 392.7 on the left hand side. The next thing we need to think about is we need to get rid of 15.7 because everything is timesing by it, so we divide by it to get r by itself. So we divide it all by 15.7. So that leaves us with 392.7 divided by 15.7. And that equals 25.01 is equal to radius squared. The last thing we need to do is to get rid of a square. We need to square root both sides. So the square root of 25.01 is approximately 5. So the radius is 5. Now the next question is the same. It's just slightly different. So again, we are using the same formula, but it says the height is what we need to find. If the radius is 7.5 and the volume is 562.8. So again, I'm just putting that information into my equation. 562.8 is equal to 1/3 times 3.14 for pi. I know the radius this time, it's 7.5. So times 7.5 squared times h. So because we know everything but h on the right hand side, we can just put it into a calculator and solve it. 1/3 times 3.14 times 7.5 squared and that is equal to 58.875. 58.875. Now we're still timesing by h. So the next thing we need to be thinking about is to get h by itself, and that means we need to divide both of our sides by 58.875. If I divide both sides by 58.875, it means I get h by itself. And that is what we are after. We are after the height. So we've got 562.8 divided by 58.875, and I'll round it to find the nearest centimetre. So we've got 9.559, which is rounding up to 9 centimetres.